In one more example, we'll look at how AC generators are affected by a phenomenon called back forces. As I showed in a previous video, the way that the AC generator works is we have a coil that's moving in a magnetic field. Because it's moving, there will be a current induced in the coil. But this will only happen in certain positions. Using the right-hand rule here would reveal that the current is zero because the motion of the wires is parallel with the magnetic field. But in other positions, we showed how the motion of a wire up in this magnetic field would induce a current that would be counterclockwise. In this vertical position, the current goes back to zero. And then when we get to this position here, we showed how the current would again be counterclockwise. We could get AC current, though, if we use conducting rings that are attached to the different terminals of the loop. Here we'd have I equals 0 again. So what is a back force, and why would it occur? Well, notice that the generator generates a current in a wire in a magnetic field. That's its whole purpose, is to take mechanical work and transform it into electrical energy. But since we have a current in a wire in a magnetic field now, that current can cause there to be a force on the wire. It doesn't come from mechanical work being done on the system. It comes from the magnetic field. So we want to use our right-hand rule, and we can do it on this segment of wire here. We should point the pointer finger in the direction of current. Point the middle finger in the direction of B. And then the thumb ends up pointing down in this situation. And that would be the magnetic force on the wire. So what we have then is we have a force on this wire. A force which is pushing opposite to the direction of motion of the wire. It's called a back force. It tends to oppose the spinning of the generator. If we do the same analysis on this wire here and point our pointer finger in this direction, our middle goes in the direction of B. We have some other fingers, and our thumb points up. So that's current. And this is the direction of the magnetic force on that wire. So this guy feels an upward force, a back force. In this situation, it would be exactly the same. The back force opposes the motion of the loop.